Hi, everyone. Thanks for joining ProjectPro Expert Talks. We're thrilled to have Anusua with us today. Anusua is a senior data scientist lead with Microsoft at Redmond, Washington. At Microsoft, she specifically works at the AI for Good Research Lab. She's been with Microsoft for almost 5.5 years right now. Before Microsoft, Anusua was with the Texas Advanced Computing Center, where she had an interesting role of solving big data problems on supercomputers. And before that, Anusua spent about 3 years on the Texas University of Utah education system as a data design engineer. And her specific area of research are around deep learning and ethical AI. Anusua, thank you very much for taking time to do this.
Yeah, thank you so much, Vinny.
Okay. We would love to hear, Anusua, what is AI for Good Research Lab? What kind of work do you do?
Yeah, so we are, as you might imagine, we are a very new team coming up with the growth of AI, the exponential growth of AI in the last 5 years. It has become eminent that you have to have some sort of control and new innovations happening around our day-to-day life, right? So how can we take this very powerful tool, which let's call it AI for the sake of it, right? And then how can we apply it to things around around us? So AI for Good Research Lab has certain verticals which we target. So there is AI for Earth, there is AI for humanitarian action, AI for accessibility, AI for health, and AI for culture and heritage. So these are the five main pillars which we target towards. There is also certain other areas that we focus on, like you spoke about ethical AI. So whenever we work on these five different verticals, there are some common things that we have to keep in mind, like how to make your model unbiased, how to make it more ethical, especially if you're working with health, there is human subject data involved, right? So how do you explore AI, but still keep it ethical so that you're not invading in the private space of a human being, right? AI for Earth is somewhere we work on carbon footprints, minimizing for the company. So Microsoft had announced to go carbon negative by 2024. So that is one of the huge pillars, because these big supercomputers, they generate a lot of carbon, right? So you have to figure out how to manage the heat and not contribute to the global warming, the big data centers. So Microsoft is building underwater data centers a lot. So we are experimenting through it, but there is also, are we actually destroying the ecology there, right? So for example, if you build such a heat emanating data center underwater, what happens to the ecological system around it, right? Are we making the soil like more is it going soft, or is the fishes around it, is there a population decrease? So all of those monitoring through video feeds come to us. We use a lot of image processing, live video image processing, uses deep learning to manage work around those. This is one of the examples. Then there is a ton of work going on with satellite imaging. One of the work I'm doing on India with a collaboration with a professor from Harvard is trying to figure out how to use unbiased sources of satellite images to figure out the socioeconomic problems in India. For example, if you take nighttime satellite images, there is a paper from a professor in Stanford which has been shown to show energy poverty correlated to the brightness of the nighttime satellite images. I mean, we all have seen in Facebook the how India lights up in Diwali in the nighttime satellite image, right? So, right. But imagine how you can use that to measure the energy poverty index, which is directly correlated to poverty. And you can then do some grant distribution based on that. So there are tons of work going on in the AI for Earth area, which you might not be thinking, oh, it's AI for Earth, but there is tons of unbiased sources of data which are coming in through it. AI for accessibility is also about, building all your products more accessible. Like Seeing AI is one of the products which came out from Microsoft, where people who are vision impaired or they're blind, then we give out small type of instructions from the app to, for example, you can work with microwave buttons. It's very hard for somebody visually impaired to go to a cafeteria and warm up food, right? So if you can just move your camera and see where the microwave is, go to there and it can read you the button, give you instructions, move hand you to your left and right. I mean, this is one very simple instruction example I'm talking about, but still that goes a big way. For example, bill currency detection. If you're traveling and you are vision impaired and you're not very familiar with the foreign money, you can hold it in front of your camera or seeing AI app, and it will say like what currency, what amount, what value you're doing the transaction with. Humanitarian action is where we work with UN and WHO a lot. I worked personally with President Jimmy Carter's center, the Carter Center org, based off of Georgia. They report weekly to UN on Syria warfare zone, and they try to figure out what are the causes of still like civilian deaths happening. Like, are there ground clashes going on? Is there some political agents involved in there? And one of the work that we did was taking all sorts of live feeds, because there is no standard news source there, like people tweeting, people blogging, small news sources, taking those, extracting and trying to create, okay, where are the clashes happening, creating a live visualization map, like a Power BI map of it, and showing which area has the highest concentration of the clashes and the deaths going on. So this report was provided to UN, and UN was able to take very fast decision based on this, and we received special recognition from Jimmy Carter for that. But that's one of the examples of one of the projects that's happening with Carter Center. There is also defending democracy, election fraud, deep fakes problems, which we are working in the humanitarian action world. There is also something new called the cultural heritage, which we started. It's about preserving all the problems around the world and trying to figure out how we can preserve language, preserve which do not have strict like script, preserve buildings around the world. So there is also some imaging problems coming in there. So these are some of the areas which nonprofits and educational institutions and hospitals work on. I didn't even touch about AI for health because that's a very big pillar, and my work mostly concentrates on AI for health. And with COVID, it has gone up like really high. We recently announced a $20 million grant program in COVID. We are inviting individual researchers as well as nonprofit organizations to come and apply for a project proposal. We go through the review process and we collaborate with them, work with them to develop ML models to solve problems in this space. So we are collaborating with, one of the examples is we worked on a project with American College of Radiology, and we have been able to develop a state-of-the-art model, which we are developing for live patients around 15 sites, including Stanford, Johns Hopkins University, and other places. So there are tons of work going on around these areas. It is empowering to see how AI is reaching to the corners, which is like we didn't ever imagine to reach.
Right, it's fascinating what you just walked through. And that got me thinking, Anusua. So things like ethical AI, AI for health, or AI in culture, AI Earth, and things like that. Those are sound like very reasonably large vision statement, large problems to be attacked. How do you come up with the specific problems that you want to work on now? Like, is that consultative? Like, who decides what problem you work on? How do you define that?
So we have a system where 80% of the lab is like external request. As I mentioned, we have a grant-based program. So all of these pillars, we give out grants, we give out money for compute, right? And we provide data science help, right? So we are basically the researchers who are collaborating with nonprofit organizations like universities or NGOs, our hospitals, and we work with doctors, we work with professors, and we, or I said with Carter Center, which is an NGO, right? So we work with them. We try to work with the domain experts who are working on the ground level, who knows what the current state of the problem is. And something which we build actually gets deployed, the end-to-end system. It's not only the research part, right? It's fun doing the research and the ML modeling part and writing it. It's never fun building the container, deploying the API, making sure this thing goes into the end-to-end pipeline system, the data is getting ingested. So there is a huge engineering aspect to it, which I'm not even touching, right? So it's not the the fun part is only 20% when you're going to on a deployment, and then 80% is basically the engineering parts, making sure whatever you build, and that's basically, I think, is the success of the data scientist. I mean, anybody can write a paper and work on a fun problem, but the major success comes when you are able to hand it over to your customer and they can actually incorporate it seamlessly into their existing pipeline. They learn about it. So one of the examples I gave about Carter Center, right? I taught them how to train and use active learning. And right now they're doing monthly training themselves. You give them such scripts and incorporate into like data breaks and stuff like that, right? Which I had no clue about. I had to learn it, right? So because I work only in like machine learning stuff, but I'm learning constantly, even the engineering component, because you're giving it out to the people and you're helping them on board. So there is a constant learning going on, even from the engineering aspect. So that, I would say, is the major challenge, that not only just developing the innovation part, but also making sure you're actually making some change in the world by making sure it's deployed in the system, it's actually working. The rest of the 20% is pure research, because you cannot stop ever pure research. You have to keep on innovating. And even if there is, and you have to think around 10 years ahead of time, right? For example, the carbon space I was talking about. It's still a pure research. Nobody is doing it at this point of time. But after 10 years, there will be a time which I think there will be products around it.
Right. Makes sense. And if I could take you back to the early years of your career, you started off being a data engineer, a data architect, and then a data scientist, machine learning engineer. Do you recall that first project that you worked on that made you a full data scientist? Where did that happen? How did that happen? How did you make the transition? Or was there really a transition?
So I'm originally from India. So I did my undergrad in India, and then I started working in one of the software companies, and I was working for GM OnStar. And there I was working on that automated voice calling thing, and I became really interested in speech recognition and stuff like that. So when I decided to do my master's, I thought, okay, maybe I'll specialize in machine learning. And that was back in 2009, and nobody was even interested in machine learning at that point of time. So I went to University of Utah, did my master's in machine learning, and then I joined UEN, Utah Educational Network, as a data architect. There I worked on we call it the longitudinal data store. So basically there's a temporal component to it, where we are trying to find out, there is a huge high school dropout rate problem in Utah. That is basically a cultural thing, because they go out to missions at the age of 17 and 18. And when they come back from the mission, they do not join the education system anymore. So there is a huge high school dropout rate, specifically in the state of Utah. And there was a federal grant which was given for the state of Utah to figure out how you can incorporate the students back. What are the factors where the investment from the government needs to go into to make the changes happen? Does there need to be a seamless incorporation for the students coming back and willing back to join? Is there some poverty related problem going on? Is there some other cultural religious belief problem which is going on? So it was a huge longitudinal data analysis which we had to do and provide this report to the government. And that was basically the whole project about. And then by doing so, we incorporated a lot of hospital data, and I became interested more and more in genomics. And then I joined TAC, which is the Texas Advanced Supercomputing Center under UT Austin. And I used to work on huge genomic sequencing using the big GPU servers present there. And by doing so, I broke Microsoft's one of the Microsoft's GPU cluster, which was embedded in there. And then they contacted me, and they were like, "Oh, yeah, we should interview you because you broke this." So that was a funny incident. But then I interviewed, and then I interviewed, and then they hired me as a data scientist. So as you can imagine, this is after my master's, and this is my first industrial job, and I've loved it. I mean, I think it couldn't have been a better time to join Microsoft at the point of time when Satya was just taking over, and the whole vision of the company changed a lot. And it has been a fabulous journey for me, working with like customers front end, flying all over the world, doing, and eventually I decided to move to research, where all the innovation was happening, and here I am. So it's not like I planned out saying that, hey, I'll have my PhD go to research.
Yeah.
It's just my course of action, which took me to where I am
Understood.
here.
That's fascinating. That kind of leads me to the next question, which is, if somebody is kind of starting off in their career right now and they want to somehow find a way to being a machine learning engineer, what can they do other than breaking Microsoft's GPU cluster to get a job?
Yeah.
Yeah. So
To be very fair, as I said, I mean, when I was starting out, ML was still something new and nobody heard about it, right? So now the competition is really tough. So to be very fair, when we interview, right, especially for the research lab,
yeah.
we look only for like PhDs and postdocs. I would not hire myself at this point of time because the competition has grown so high, right? And there is an influx, there is like a huge pool of talent to choose from. Uh, so one of the things I would say is like try things hands on, because many of the time I've seen it, you have a really good degree and you have a really good background in your resume, but when you come and do, I'm very, as you can imagine, I came from being an engineer, right? So I'm very hands on. I believe in like if you cannot code, um, you're not hired, right? So I think you have to have that hands-on experience. Theory is good. There are theoretical scientists. So believe me, in my team, I'm the only computer scientist. Everybody has come from economics, psychology, but all of them can code
Cool.
amazingly.
Yeah.
Right. So that is where I'm coming from. It does not matter if you're coming from your engineering background, from your machine learning background or anywhere, right?
Yeah.
If you can code, you will find a way to figure out how to do, because it's a matter of implementation and innovation comes from the reading and the theory part, but if you cannot implement, you cannot. So one of my major takeaway is learn how to code. Do not just take samples as like the prototype and work from it. Obviously that's a good starting point, but learn how to code, learn where the changes are happening, and that's where you can say, okay, this is where the padding is, so maybe if I change the padding a little bit, it might work better for this type of data. If you can have that kind of association established in your mind,
Yeah.
then nobody will be able to stop you. I mean, you would get hired for sure.
Understood. And as one goes through this path of getting hands-on experience and doing kind of use cases, and people usually start on online forums, resources to get ideas on how to do it, and they'll probably get public source data sets to do these things. And they do that and they get a job and they start working on a real production project. What are some accesses in which a real project differs significantly from these use cases they might have got their experience on?
Right. The whole end-to-end pipeline thing, which I was talking about, right? I mean, the innovation is only 20% of the thing. The rest of the stuff is the engineering portion, right? And that's where you need to learn how to code. So you can build a very good model. You can have an accuracy of 99%, right? If you want. But if you're not able to containerize your model, create an API, a REST service out of it, figure out how the data is getting ingested into that REST service and getting the inference put out in the manner the customer wants, then your model fails completely. And I think that is what is lacking in all this challenges that you see online, right? So one of the things which I like is the open hackathons, right? So there are hackathons which happen. Kaggle sometimes hosts them. I think there is a research platform called Prolific, which also hosts this kind of hackathons or research calls. So those are the places which I think you can definitely go and try to do hackathons. Kaggle projects are really good for the innovation part, for the ML learning part, for creating the ML bar. I think the problem comes when you join, say, a Bing team, right? A Bing ads team maybe works on an ML problem, which curates ads and stuff. But if you are part of the engineering team, you have to learn how to incorporate that feature into the existing stack with like minimum intervention and not breaking anything else, right? Because it's actually going to production. So that's the testing of your stuff, writing the testing suites correctly, right? Basic thing, unit testing. Data scientists don't do it. If you are working on an actual problem space, you need to learn how to test your suite for all probable things, figure out what it's getting attached to, what is being output, test those things out so that when you're putting that, it's to me, it's kind of a Lego, right? You have the stacks already existing. You want to put another stack joining it. That is your feature. That is your ML model. And if by doing it, you break the existing stacks, then there's a failure. So you have to figure out how to put the Lego block on top of the existing blocks and not break it. So that I think is the key when you go to the real world application.
Okay, understood. Okay, cool. And when you're typically hiring kind of machine learning or deep learning kind of engineers, are there some favorite questions you like to gauge them on, or favorite projects, kind of projects you would like to see on their portfolio?
Yeah. For us, it's a very varied thing, right? So if you go, as I was saying, Bing, right? They work on a ton of text data, right? So if you go to them, they will ask, if as an ML engineer, they will ask you more about optimization, because optimization is a huge thing in search engine stuff. So they'll ask you about optimization. They'll ask you about text related stuff, NLP questions and stuff. For us, it's a little bit different, right? For us, it's a varied thing. So we need a skill set in imaging, not only imaging. We want to figure out what types of imaging you've worked on. If you've worked on satellite imaging, or if you've worked on chest x-rays, or if you've worked on very specific chest x-ray like puppets, right? So it's very deep for us, like what kind of imaging you've worked on. Then there's for text, right? What types of text have you worked on? Social media text, or is it like documentation text, or is it like insurance, a medical thing, right? You know, there is tons of stuff that we cover. So even in like NLP imaging and any kind of like numeric stuff that you're working on, right? Optimization problems, you have to figure out like which team you are going for, what product they build, and what is the type of question they can ask. So if you gauge that, like, for example, as I said, Microsoft is a big company, but we have different types of products, right? So if you know, for example, if you're going for Microsoft Teams interview, we are doing it on a Zoom call, but if you're going for a Microsoft Teams interview and you're interviewing, you know, they will ask you about video a lot. Right. So that's basically the type of, when you're going for an interview for a particular company, for a particular product, or if you do not know about a particular product, you're going for a startup and you know what field they work on, try to find out most about that field and see where the ML is going in that field and prep for questions on that.
Interesting. Okay, terrific. Well, Anusua, I mean, we would love to see, you know, any specific resources the community could work on that the AI for Good Lab offers.
Yes, let me share my screen.
Sure, please.
So this is basically our AI for Good Lab website. As you can see here, there is AI for Earth related stuff, right? And you can see all the different types of projects you can go inside. We have AI for Health, like how we support COVID-19 on all the different types of tough issues. I'm not going into the details. There is tons of videos in there. There's AI for accessibility, as I spoke about, that you can go and learn about. And there is AI for humanitarian action. If you go into, there is cultural heritage too here. So if you go in there, you will see what the project is working on. There are GitHub resources. Some of the GitHub resources are open and associated with the website link. There is another thing which I wanted to show, which is the Azure Cognitive Services. You can try the cognitive services for free. And what you can do here is when you create an Azure account, where you are given around $200 credit for free, and you can go in and learn about all the different types of services you have here. So if you're trying to build an anomaly detector, a content moderator, a metrics advisor, a personalizer, all of this is there. For example, in language, right? If you want to make a Q&A maker, a text analytics. So for example, there is tons of stuff in speech, there is in vision. Let me show you something like face recognition, you try to do face, like some of the face detection, right? So as you can see here, they're trying to select the face here, right? So if you see here, you can also see it selects a face and not the and this is actually being used by Uber, the same API. So for the Uber driver recognition, and there is tons of there's tons of stuff, and basically figuring out, okay, this is the driver who was supposed to pick you up and those kind of stuff, right? So in their matching, they use this API. So there is tons of stuff which you can do. Face is just one thing that I showed you. There's demo, there are features, there's product review, there's documentation in there. You will find all the GitHub codes and stuff like that in there. So there is tons of stuff which people can use, and when we are doing it, as you can see, there are different races of people it's detecting correctly. There was a huge news before that, okay, people who are of darker complexion, it's not getting a good recognition for some of the bigger companies. But we tried to address those kind of things, and we have built a multiracial facial recognition, which works mostly for globally overall. So these are some of the resources from Microsoft coming in. There are obviously people use Kaggle a lot. There is Coursera courses, which I like, and there is by Andrew Ng. I really like that course. There is also some Udemy courses which I like, which especially by the Google founder. I really like that course. So there is tons of courses out there if you want to. There are theory of Bayesian modeling, which is the Bible of machine learning. So if you're interested in theoretical ML or learning basically the theory of machine learning rather than the applications of it, then that is another book which I can suggest. All right, so that's really a good book to, if you like theory, that is to go with. So yeah, so there are tons of resources to go for. We are open to collaboration for all nonprofits, researchers, and stuff like that. You can always email us, reach me out to LinkedIn if the project is interesting enough. I try to respond to as many people as I can in LinkedIn, but as you can imagine, there is tons of requests coming in. So you might not hear from me, but I try to go through and try to respond to most of the people.
Super. I mean, we'll certainly share your LinkedIn profile with the viewers if they want to reach out to you. And is there a specific place where if people want to apply to grants, they can actually do that?
Yes. So the AI for Good website that I showed you. So there is a grant information, and then there is a project information there. So every page has its own grant information, and there is a form which you can fill out, which gets then submitted to the system, and then the review happens, and then you will if your project is innovative enough, it gets selected, and then you are given a Azure grant, and then one of the scientists from my team or some of the sub teams get assigned to work with you.
Terrific. Super. Well, this was fantastic, Anusua. Thank you very much. Lots of actionable stuff in here. Yeah. Thanks for taking time.
Thank you.